Hey, fifth graders, these are the test review slides, test review number 2. So follow along, do examples in your journal if you have to, and feel free to watch this again. The questions are modeled after the test questions, so they'll help you identify those skills and strategies you need to solve 4 questions on the test. Here we go. Okay, so the first one we have is a multi-step problem. Let's read it. The gaming convention is picking up all professional gamers from the hotel. There are 146 pro gamers, 14 staff, and 3 coaches. The buses they are taking can each hold 45 people. Remember, each means 1, so one bus can hold 45 people. How many buses will they need? And the answer statement says the convention would need blank buses. Okay, so let's move this out of the way so we can get some work done here. So this is multi-step, so I know I'm going to have to do 2 different operations to solve this. So I need to figure out first how many people are going, because that's going to tell me how many buses I'm going to need. So I have to figure out all of the people. I have 146 pro gamers, I have 14 staff, and 3 coaches. So if I add all those together, that'll give me the total number of people that are going to this convention. So I've already used adding. 6 plus 4 plus 3 is 13. 4 plus 1 plus 1, 4, 5, 6, and 1. So there's 163 people. That is all of the personnel that will be riding the bus. Now, the second part of operation is the buses they're taking can each hold 45 people. How many buses will they need? Okay, well, I can use my get strategy here too to figure out if I need to multiply 163 times 45 or if I need to divide it. So, again, I'm going to ask myself this question. Do I have a total? And I do. The total number of people I have is 163. Okay, I need to figure out how many buses they're going to take. Because it says how many buses will they need? Well, I have the total, which is 163, and I'm going to be dividing that by the number of people they can hold. So they each holds 45, and that's going to give me how many groups of buses I need. Okay, so we can set that up like a long division. 163 divided by 45. Okay, so since this is long division, I'll go ahead and solve this one with you. Let's change the color so we can see a little bit better. Okay, 45, that's my 2-digit number. Divisor goes into 1, 0. There are no groups of 45 in 1. How many groups of 45 are in 163? I'm sorry, in 16, that's 0 as well. And then under 163, how many groups of 45 are there? Okay, so at this point I know that I have to start my guessing check. So I like to start with Old Faithful, which is 5. So let's see if there's 5 groups of 45 in 163. 5 times 5 is 25. 5 times 4 is 20 plus 2 is 22. That's too many. I need to come down some. Maybe let's try 3. Let's try 3 groups. 3 times 5 is 15. 3 times 4 is 12. Plus 1 is 13. Okay, that looks like it could work. So we'll have 3. 3 groups of 45 is 135. Now I can subtract. Let me give myself a little bit more room here. There we go. 3 minus 5, I can't do that. So let's regroup from this 6, make it a 5. This becomes 13. Second grade math skill. Second grade. 13 subtract 5. Sorry about that. My iPad was about to die. Charge it. 13 subtract 5 is 8. And then 5 minus 3 is 2. Okay, so here's where I have a dilemma. There are 3 groups of 45 into 163, but then I have a remainder of 28. So I could try to make this a decimal, but it's asking how many buses I will need, and a bus cannot be a decimal. I cannot have 4/10 of a bus. It's either one whole bus or not. So if 3 is not enough buses, and I have a remainder of 28, so there'll be 28 people that cannot go to the gaming convention, I have no choice then but to add 1, and instead of taking 3 buses, take 4 buses. And that 4th bus will just have 28 people in it. Good job, guys. Okay, this is a single problem. I think it meant to say single step problem, but we get it. The candy store sells Skittles by the pound. Sounds like my kind of store. If my bag has 2 3/10 or 2.3 pounds of Skittles, and it costs $1.50 per pound, how much will my total cost be? Aha. So I use my get strategy again here. Groups each and total. And I just go with that same strategy I've been showing you so far through these slides. Do I have a total? Do I have a total? Well, it's asking me how much my total will be, so I don't have a total, which means I will be multiplying. And this is a decimal times a decimal, so I will help you, and we'll do that one together. I like to put the 3-digit number on top. Just makes me feel more comfortable. $1.50 multiplied by 2.3. Now the thing about multiplying decimals, if you remember, we don't have to line them up. We actually ignore them. I know it's kind of rude, but we're going to ignore the decimals. And at the end, after we get our final product, then we'll count the decimal places and move them. That's kind of the cool thing about multiplication and decimals, is we can kind of ignore them at the beginning, multiply just like there was no decimal, and then at the end on our final product, we will put the decimals back. So we're going to do this just like a standard 3x2 multiplication. Start in the 1 spot, and we multiply by everything on top. So 3 times 0, 0. 3 times 5, regroup the 1, that's 15. 3 times 1 is 3, plus 1 is 4. So I finished multiplying the ones place by everything on top. Now I'm going to start with the tens place. And since I'm starting to multiply in the tens place, my first digit's going to go in the tens place, which means Bob has to show up here, do his job, and hold that place for me. So I can start multiplying the tens place. 2 times 0, 0. 2 times 5 is 10. And 2 times 1 plus 2 is 3. So I add my 2 partial products together. I get 0, 5, 4, 3. So 3,450 seems like a lot of money to pay for a little bit over 2 pounds of Skittles. So I can't forget my decimals. I have 2 decimal spaces here, and I have 1 here for a total of 3 decimal places. So I'm going to start all the way on the right and move my decimal 3 places. 1, 2, 3, right between the 3 and the 4, which makes that $3.45. Much more reasonable answer, right? About $3.45 is way closer than $3,000 for about 2 pounds of Skittles. So good job. Okay, solve, then choose the model. So anytime you have models in your word problem, my advice is always to solve the problem first and then look for the model that matches your answer. That'll work most of the time, so let's do that. If I have 3/10 or 0.3 ounces of salt, and the cost of salt is 70 cents per ounce, which model represents the amount of money I would pay? Okay, so I have 0.3 ounces of salt, and it's 70 cents per ounce. So I'm going to be multiplying those two numbers. And also just by looking at the models, I can tell that these are models of multiplication because they're the overlap models. And I'll show you that in a minute. Okay, so we have 70 cents multiplied by 3/10. Again, we're going to ignore the decimals and just multiply like standard 2 by 1 here. And we'll do our decimals at the end. We'll put the place values there. So let's do that. 3 times 0 is 0. 3 times 7 is 21. That's an easy problem. 1, 2, 3 decimal places. 1, 2, 3. So the decimal is before the 2. So that means it's going to be 21 cents. So which model represents 21 cents? Now remember, when I'm dealing with these, let me see if I can get close to one of these. When I'm dealing with these models and I'm multiplying decimals, 3/10, and 70/100, or that could also just be 7/10, right? If I decided to leave the 0 out, it could be 7/10. So I'm looking for a model that has 3/10 going this way and 7/10 going this way, shaded in. And then the area that's overlapped will be my actual answer. That'll be the right one. The other way to think about it is to count all of the dark shaded in boxes, right? There's a dark shaded in boxes here. I kind of wrote all over this one. Let's erase this. There you go. And there's dark shaded boxes here, and there's dark shaded boxes here. That represents where the two numbers have overlapped. So my answer is 21 cents. Also could say that it's 21/100. So I'm looking for the dark shaded box that has 21 boxes shaded in. I'll let you count those. It's pretty easy. But what I want you to realize is the way that the model works. See if I can get a highlighter going here. Is I have 7/10 going this way. 1, 2, 3, 4, 5, 6. There's my 7/10 or 70/100. And the other way, I have my 3/10. 1, 2, 3. So that tells me right there that this has to be the model, because it has 7/10 going this way, 3/10 going this way, and inside the square I'll have, in fact, 21/100. Okay, so that's how you solve that one. Solve it first, and then look for the model that matches. Okay, we have here a single step problem. Looks like the equation is mostly written out at the bottom for me. I just have to fill in the blanks. So if I have $4.50 and I want to spend half of that money on a drink at Valero, how much money will I spend? Write the equation in the box below. A lot of people struggled with this one, and it's because of this right here. Half. What is half of $4.50? That's what it's asking me. I want to spend half of that $4.50. Well, I can see obviously here it's a division problem, so I'm dividing. But more than that is understanding what the half means. So if I draw, let's say that this is represents 2, and I want to cut the 2 in half. I draw a line down the middle. On this side I have 1. On this side I have 1. Let's say I have the same box, but this one's going to represent the number 4. If I want to cut 4 in half, I cut it in the middle. On one side I have 2. On the other side I have 2. If I have yet another box, and let's say this one represents 8. If I want to cut 8 in half, I split it right down the middle. On one side I'll have 4. On the other side I'll have 4. So what's the same about all these? How many pieces do they have? This one has 2 pieces, this one has 2 pieces, this one has 2 pieces. Because when you cut something in half, you are dividing it by 2. Okay, so that's what I'm doing to this $4.50, dividing it by 2. And that's a pretty simple problem. I'll let you work on that one yourself, but I'll help you set it up down here at the bottom. $4.50 divided by 2. Now remember what we do with our decimal when we're doing division. Paula Abdul said, straight up. Bring it straight up. There you go. Not that high, but right there. So the decimal can come straight up to the top, and then you're done with the decimal. It'll stay there. All right, good luck solving that one. And here we are at our last slide, and it is a single step problem as well. Each car race takes 84.9 minutes to finish. How long would it take to drive this race 2.3 times? Remember, decimals are okay in measurements, right? Length, weight, time can even have decimals, but decimals are not okay in physical objects, buses, people, tables, chairs. Can't have decimals of those. But just wanted to make that note. Let's look at the problem. Each means 1, so one car race takes 84.9 minutes to finish. How long would it take to drive this race 2.3 times? And this is the key here, this word times, right? It's telling me to multiply. And also, even if I did my get strategy, I would know that I'm looking for a total, right? Or the total time it would take to finish. And this is multiplying a decimal, so I'll help you set this one up. 84.9 times 2.3. Now remember, the decimals don't have to line up when you multiply, they just happen to on this one. And when we multiply decimals, we don't, once they're in the problem, we leave them there, and then once we get our final product, we'll count the decimal places and add it to the final product, which I can see here there's 2 decimal places. So once I get my final product, there will be 2 decimal places at the end. You know what? We'll go ahead and solve this one together since it's the last slide. Okay, I'm going to start with the ones place. That means I'm starting with a 3 and multiplying everything on the top, going from right to left. So 3 times 9, 27. 3 times 4 is 12, plus 2 is 14. And 3 times 8 is 24, plus 1 is 25. So I finished multiplying the ones place. That means now I'm going to be working in the tens place. So I'll start at the tens place here, which means that Bob has to come to work, and he's not happy about that, but he's going to hold that place for us. So now same thing, I'm going to multiply all the numbers on top by 2, which is in the tens place, starting on the right, going all the way to the left. 2 times 9, 18. Regroup the 1 up top. 2 plus 4 is 8, plus 1 is 9, and then 2 times 8 is 16. There's nowhere to regroup the 16 here because there's no digit. So when I have 2 times 8 for 16, I just bring the 16 and write it down here. And I add all those bad boys together. 7, 8 plus 4 is 12, 10, 15. Regroup the 1, 6, 7, 8, 9, and a 1. And then I look at my decimals. I said I had 2 of them, so 1, 2. So it looks like it's going to take me 195 minutes, or 195.27 minutes. Okay, so that's how you solve that one. Good luck again. Feel free to do these over and over until you remember the pattern. Good luck on the test, and I'll see you on the next review, which will be coming shortly. Bye-bye.